lecture, we will talk about copies and views and the difference between NumPy arrays and Python lists. First, let us see the copies or views of NumPy arrays. If you assign one array to A to another array B, for example, you are not copying it. The array B is just another way to call array A. In fact, by changing the element of A, you change the value of B too, and vice versa. So A is an NumPy array with 4 elements, 1, 2, 3, 4. Then if we assign A to B, then B and A actually are the same object under the same view of the object. So if we change the value of the third element of A to 0, then the B's corresponding element in B is also changed. And when you slice an array, the object returned is a view of the original array also. So if we write a C is an array and the value is the slice of array A, that's from first to second object. So, and if we modify the value of the first element in A to 0, then C's corresponding value is also changed. And for NumPy array, if you want to generate a complete and distinct array, then can use the copy function. So A is an array with 4 elements. Then if we write a C is A.copy parentheses, then C is has the same value as A, but C and A are not the same object. So now if we modify the value of A's element, first element to 0, then C's value will not be changed. And copies or views of Python lists. So if you assign one Python list A to another list B, you are not copying it. List B is just another way to view list A. This is same as in NumPy array. So by changing the element of A, you change the value of B too, and vice versa. So if A is a list with 4 elements, and we assign A to B, then next we append a value to B, and we change one element in A to 10, then both A and B are also changed and will be the same. And when you slice a Python list, the returned list is a distinct and a new object. So this is different from NumPy array. For example, A is a list with 4 elements, then F is a list, and the value is the slicing of A's first 3 elements in A sliced. Then next, if we modify second elements in A to 10, and we append a value 100 to F, then A and F will be changed individually. And when you use a copy to a Python list, the returned list is a distinct and new object. So this is same for list and NumPy array. And A is a list. Then if C is A.copy, then C will have the same value as A, but C and A are 2 separate objects. So now if we modify the second value in A to 10, and same time we append one value 10 to C, then A and C will be changed individually. We will show all these statements in Anaconda Spider now. So we see the file called section 10, the NumPy library.py, and the links to the file has been put in the description of this video. So first, and we move to the lecture 6, copies and views, difference between NumPy array and lists. So first we see the copies of views of NumPy arrays. So if we import NumPy first, then we create an array A with 4 elements. Then next we assign A to B. We show A is an array, B2, they are the same. Then next, if we modify the third value in A to 0, we see how it happened. Then show A again. This value has been modified. Then we show B. B's value also modified. So A and B actually are the view of the same object stored in the PC. So yeah, A and B both modified. Then we next see slicing of NumPy array. So C is an array, but the value is the slicing of A from first to second element. You create a C, first and second elements in A, sliced to C. Then next we modify A's first value to 0. Then we show A's first value to 0 now. And we see this value also to 0. So in NumPy array, both assignment and slicing are the view of the same object. Next we use copy in NumPy array. So A, we create A again with 4 elements, 1, 2, 3, 4. Then C is A.copy. So A 1, 2, 3, 4, C also 1, 2, 3, 4 because C is a copy. Then next we modify the value, one of the value in A to 0. This value has been modified. Then we see C not changed. So copy is we'll create a new object in NumPy array. Not the view, not the view to the original object. And next we show these cases in NumPy list. Not NumPy list, the only list, Python list. So first we see the assignment. If A is a list, and then we assign A to B, so B is also a list. A is a list 1, 2, 3, 4. B also a list 1, 2, 3, 4. Next, we append one value 5 to the end of B, and modify one value in A to 10. We see what happened. Now A, the second value has been modified to 10, and A also has been appended a one value because we append a value to B, but B and A both are the view of the same object. So A will also has been appended with a value. Of course, B is the same. B's second value also be modified and one value appended. So assignment for the list will be a view to the same object. So for the list slicing, we create A first. Then F is the slicing of A's first 3 elements. So A is the 1, 2, 3, 4, and F the 1, 2, 3. So next, we modify A's second value to 10, and F append one value 100. We see what happens. So A second value has been modified to 10, and F second value not modified and one value appended, and A has no value being appended. So this means for the Python list, slicing is not view. Slicing will create two separate objects. So next we should the copy for list. A is a list, then C is the copy of A. You see A, C, to same list. Then A's second value will be assigned modified to 10, and the C is appended a new value. Then A second value modified, and the C second not modified, but one value has been added. So for the Python lists, copy will create a new object and not the view of the first object being copied. So for Python list and the NumPy array, copy and assignment has the same feature, but the slicing are different. So for Python list, the slicing will create a new object, but NumPy list slicing will also be the view to the same object.